the numerical problems on the Coulomb's law concept. Here we consider two or more charges distributed like at the corners of a triangle, corners of a rectangle. Okay, so that the first one is 3-point charges are placed at the corners of an equilateral triangle separately. The magnitude of each charge is 10 to the power minus 8 coulomb. Calculate the force on any one of these charges due to the other two charges. Okay, the side of the triangle is 1 meter each. This is very easy question. Okay, so this is the diagrammatic representation of this theory. Okay, so here we have three charges. Let's consider this is the equilateral triangle. Equilateral triangle means what? All sides are equal. This side 1 meter, this side 1 meter, this base is also 1 meter length. If that is 1 meter means this angle will be how much? Same, this will be 60, this will be 60, and this will also be 60. If all sides are equal means all these triangles will be equal. So then what we need to find? We need to find the force, calculate the force on any one charge. I am considering this charge present at the vertex C. Now, since this one is positive charge, 10 to the power minus 8 coulomb is positive charge, and this is also 10 to the power minus 8 coulomb positive charge. Okay, the force on this one due to this one will be repulsive, so that will be in this particular direction. Let me consider that as Fa. Then force due to this one on this one will be in this particular direction. Let's consider that is Fb. Force due to charge at B, and this is force due to charge at A on this one. We have already studied that if we have two like charges, the force or the nature of force between them is repulsive. You can take plus plus or minus minus. They repel each other. In the same manner, I am not finding the force on this one due to this one, but I am finding the force on this charge due to this charge and force on this charge due to this charge. So we have Fa and Fb, but the resultant force will be in this particular direction. This is the resultant force. So we need to find the resultant force here. Fa is only due to this charge, Fb is only due to this charge, but this resultant force is due to both Fa and Fb. Okay, so how to find Fr resultant force? That is given by square root of Fa square plus Fb square plus 2 Fa into Fb into cos theta. This formula you already know, and this you have studied in vectors. Do remember that. Okay, so first I will find out Fa, then I will find out Fb, then we can substitute that here to find out resultant force. Okay, and this angle theta is nothing but this angle. How much is that? 60 degree. Theta here is 60 degree. Simple. So formula is there. Let's find the answer. So Fa, according to Coulomb's law, force between any two charges is given by 1 by 4 pi epsilon naught Q1 Q2 by R square. So that is equal to 1 by 4 pi epsilon naught is how much? 9 into 10 to the power 9 into Q1. So we are finding the force between these two. So Q1 can be considered this one 10 to the power 8 minus 8, and Q2 is 10 to the power minus 8 here, divided by R square is the distance between them 1 meter whole square. So if we solve that, how much will get? 9 into 10 to the power 9 as it is into 10 to the power minus 16. So then it will give 10 to the power 16 minus 16 plus 9 is minus 7. So this is the force Fa. Okay, force on the charge C, charge placed at C due to the charge placed at A. Then next one, force on the charge placed at C due to charge placed at B is given by Fb, that is equal to 1 over 4 pi epsilon naught q1 q2 by r square, or you can consider it as q3 also, q2 q3, because we have already considered this one as q1. Okay, so q1 q2 q3, now q2 q3, so that is equal to 1 by 4 pi epsilon naught is 9 into 10 to the power 9 into q3 is 10 to the power 8 minus 8 into q2 is 10 to the power minus 8 divided by distance between them is 1 meter. Okay, so this will also give the same answer like Fa, because the magnitude of forces and the distance are same, so you will get 9 into 10 to the power minus 7 Newton as your answer. This is Fb. Okay, Fa and Fb. So Fa is 9 into 10 to the power minus 7 Newton, that will be in this direction. Fb is same, 9 into 10 to the power minus 7 Newton, that will be in this particular direction, but the resultant force will be in this particular direction. That is this. Let me solve that. So Fr, resultant force is square root of Fa square plus Fb square plus 2 Fa into Fb into cos theta. Okay, so here Fa is 9 into 10 to the power minus 7 Newton whole square plus Fb is what? Same, 9 into 10 to the power minus 7 whole square plus 2 Fa 9 into 10 to the power minus 7 into Fb 9 into 10 to the power minus 7 into cos theta is 60 degree, isn't it? The angle theta value is how much? 60 degree. This will be equal to this angle, that is equal to 60 degree, right? So this angle will be equal to this angle. Okay, so that's why theta is 60 degree. So then that is equal to 9 into 10 to the power minus 7 whole square plus this one 9 into 10 to the power minus 7 whole square plus 2, 9 into 10 to the power minus 7 into 9 into 10 to the power minus 7, that is 9 into 10 to the power 7 whole square. Cos 60 is 1 by 2. Here 2 will cancel out within the square root. Then we have 1, 2, 3 times 9 into 10 to the power minus 7 whole square. So that is 3 times 9 into 10 to the power minus 7 whole square. So then it is square root of 3 into square root of this one, 9 into 10 to the power minus 7 whole square. So here square root and square will cancel out, simple mathematics. So square root of 3 is 1.73 something into 9 into 10 to the power minus 7, that is 1.73 into 10 to the into 9 into 10 to the power minus 7 is 15.58 into 10 to the power minus 7, and the unit will be Newton because this is resultant force. So this is the final answer. Thank you. Students, we have the second question here. So let's start this. The electrostatic force on a metal sphere of charge 0.4 microcoulomb due to another identical metal sphere of charge 0.8 microcoulomb, it is negative, in air is 0.2 Newton. That means the force between this charge and this charge separated in air is this much, but what is the distance between them? That they have not given. That is what we have to find. Okay, find the distance between the spheres and also the force between the same two spheres when they are brought into contact and then replaced in their initial positions. Okay, so here we have two cases. One is, first we have to find out the distance. Okay, let us do that first, then we'll move on to the case 2. Now, according to the case 1 and this data, I can write this, I can draw this diagram. Look at this. We have two spheres. One is 0.4 microcoulomb and the other one is minus 0.8 microcoulomb. They are separated by this some distance that we don't know, that we have to calculate. And F is given. Force between them is 0.2 Newton, that I have written here. So according to Coulomb's force law, F is equal to 1 divided by 4 pi epsilon naught q1 q2 divided by r square. Okay, we know what is F. How much is that? 0.2 Newton. That is equal to 1 by 4 pi epsilon naught. Value is how much? 9 into 10 to the power 9 into q1 is how much? 0.4 micro coulomb and q2 zero point 0.8 micro coulomb. Okay, divided by r square. Okay, we need to find r. That r will come to this side. Okay, r square is equal to 9 into 10 to the power 9 into 0.4 micro means 10 to the power minus 6 into 0.8 micro again 10 to the power minus 6 divided by 0.2. So r square is equal to, if you solve this, 9 into 0.4 into 0.8 divided by 0.2 will give you 14.4. 10 to the power 9 minus 6 will give you 10 to the power minus 3. So if you want to solve for r value here, so this square will come this side, so that you will get square root of 14.4 into 10 to the power minus 3. If you have calculator, directly you can calculate this. Otherwise you can solve like this: square root of 144, shift this point this side, you will get into 10 to the power minus 4. So we know square root of 144 is 12 into 10 to the power minus 4 is square root of 10 to the power minus 4 is 10 to the power minus 2. This will be in meter. So this is the r value. R is equal to 12 into 10 to the power minus 2 meter, or 0.12 meter. So this is the distance between these two charges. How much? 0.12 meter. Here R value is equal to 0.12 meter. Okay, so this is case 1. Then what's happening here? Find the distance between the spheres, that is done, and also the force between the same two spheres. We already have one force, that is how much? 0.2 Newton. But look at this. Find the force between the two spheres when they are brought into contact and then replaced in their initial positions. So first we have to bring them in contact. So then what happens? Charge distribution takes place. Then we have to separate with the same distance, that is 0.12 meter. Those two charges into contact, this one and this one. So one is 0.4 microcoulomb and the other one is 0.8 microcoulomb, negative. When they touch each other, charge distribution takes place. So both will get equal charge. So how much is that? That is calculated by magnitude of first charge plus magnitude of second charge divided by 2. Okay, so that is equal to magnitude of first charge is 0.4 microcoulomb plus magnitude of second charge is 0.8 microcoulomb divided by 2. 0.4 plus 0.8 is how much? 1.2 divided by 2 microcoulomb, that is nothing but
0.6 microcoulomb. That means each acquire 0.6 microcoulomb of charge. Okay, now they are separated with the same distance. They are separated with the same distance, that is 0.12 meter. So charge on this one is 0.6 microcoulomb, charge on this one is 0.6 microcoulomb. So force between them is how much? This is what we have to find out. Simple. So F is equal to 1 over 4 pi epsilon naught Q1 Q2 by R square. Okay. Now 1 over 4 pi epsilon naught is how much? 9 into 10 to the power 9 into Q1 0.6 microcoulomb into Q2 same 0.6 microcoulomb divided by distance between them 0.12 whole square r square, right? So that is equal to 9 into 10 to the power 9 into 0.6 into micro 10 to the power minus 6 into 0.6 micro 10 to the power minus 6 divided by 0.12 whole square. And if we solve for this, you will get somewhere around 225 into 10 to the power minus 3 Newton. Then that is equal to 0.225 Newton. So this is the force between two charges in second case. Okay, this is second case. Thank you. Okay, we have the third question here. Three charges are placed at the vertices of an equilateral triangle of side A, as shown in the following figure. The force experienced by the charge placed at the vertex A in a direction normal to BC is. So we have a triangle here A, B, C. Okay, so three charges are placed at the vertices. So one is vertex A, second one is vertex B, and the third one is vertex C of an equilateral triangle. Equilateral triangle means all sides are equal. This side A, this side is also A, and this side is also A. So all sides are equal. Obviously, all inner angles are equal. So the force experienced by the charge placed at the vertex A. So force on the charge at vertex A in the direction normal to BC. Normal to BC means perpendicular to BC. Normal means perpendicular to BC is how much? Let me check that here. So this one is positive charge, this one is also positive charge. The nature of force between two positive charges is repulsive. So we are finding force on this one, so force due to this one and this one will be repulsive, so that force will be in this particular direction. Force will be in this particular direction. And here we have negative charge minus q. This one is positive charge. The nature of force between two unlike charges is attractive. So that's why this charge attracts this charge. So force on this one will be in this particular direction. Okay. So force due to C, charge at C, Fc is in this particular direction. Force due to charge at B will be in this direction, and the resultant force will be in this particular direction. Okay, and what is the, according to question, we have to find the force experienced by the charge placed at A in the direction normal to BC. Normal to BC, no force is acting. The actual force is acting is this one, parallel to BC in this particular direction. Okay, so normal to BC, no force is acting. So force acting normal to BC is 0. Normal to BC is 0. That's it. Thank you. So we have the fourth question here, dear students. So here 4-point charges QA 2 microcoulomb, QB minus 5 microcoulomb, QC 2 microcoulomb and QD minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeter. What is the force on a charge of 1 microcoulomb placed at the center of the square? Means we have this square here. We have this square here. Each side is of length 10 centimeter because it is a square. So this length will be equal to this length, will be equal to this length, and that will be equal to this length. All sides are equal. And we have four charges. One is 2 microcoulomb, minus 5 microcoulomb, 2 microcoulomb, and minus 5 microcoulomb, arranged orderly A, B, C, D according to that. Okay, so now we will put one more charge here whose value is 1 microcoulomb at the center of the square. And what is the force, total force acting on it? Okay, let me calculate that. So force due to this one and this one is repulsive because this one is positive charge, this one is also positive charge. So by using Coulomb's law we can find that. But before finding individually, let me calculate or let me check in how many ways the force is acting on this. Okay, force due to this one and this one is this, in this particular direction. So this is force due to charge at C. Let me write FC. And this is force due to charge at A. Let me write FA. Then we have these two charges. So this is, what is this? Negative charge. This one is positive charge. The force of attraction between the two charges will be in this direction. So this is FB, and this is negative charge, and force on this one will be in this direction. That is FB. Now look at this. Just by analysis only we can tell here 2 microcoulomb is there, here also 2 microcoulomb is there. This distance is equal to this distance. Force due to this charge and this charge will be equal to force due to this charge and this charge, so that FA will cancel out with FC. FA is equal to FC. Magnitudes same but opposite in the direction, so they cancel each other. Then in the same manner, this one is minus 5 microcoulomb and this one is also minus 5 microcoulomb. This will be pulling this charge in this particular direction and this will be pulling this charge in this particular direction. So there also FB is equal to FD. Okay, so magnitudes are same but opposite direction. Those two will cancel out. So the net force acting on this charge is 0. Okay, net force acting on the charge is 0. That's it. Thank you.